But why we have to collect the household battery? Where is my friend who asked me this? This is household batteries. There is always two sides, like the moon, the dark side and the light side. Light side, lot of batteries, a lot of metals, lot of critical metals, like tin, you remember, zinc, lithium, nickel. So batteries are source of valuable material. Dark side, all of the red have some problem. Each one has some problem. And you can just take the MSDS, you will see. So there is a huge dark side of household batteries too. Mobile phones, today is a reality. This is yesterday. It's finished. This is today. Very, very useful for this lady. And there is huge growth, really huge, huge growth of the mobile phone on the world, in the world. There is around 2 billion of mobile phones. This means that just for the lithium batteries, we have 100,000 tons of batteries, which is a worldwide consumption of the cobalt. But the cobalt is used other way. It's only that, for instance, the research at Ariane is making a new chemistry, not based on cobalt, to decrease the impact of the cobalt, to use nickel, manganese, iron, phosphate, etc. Otherwise, it's impossible to face to the demand of the cobalt, because don't forget that the cobalt is used also in the stainless steel, in the fine chemistry, etc., not only on the batteries. So if we increase by 5% the consumption of the batteries in electrical vehicles, there is now any more cobalt available. And now we see the geopolitical, typical of the lithium in comparison to the first slide I showed you. When we speak that one country is rich in cobalt, in lithium, for instance, Bolivia, the concentration is, for some chemists, makes sense to compare 0.025% of lithium, and they said that they are rich. Same for Chile, same for Argentina, and China start now to exploit some lithium resource. And Korea and Japan, which are high producer of lithium, really scare the feeding of the lithium, and then they start a very huge project to recover the lithium from the seaside. Just knowing that there is 1 ppm of lithium in the sea. And they believe that 1 ppm makes sense for the autonomy and for the economy and for the independence in regard to the lithium. And then what happened to the urban mine for the lithium? To produce 1 ton of lithium, due to the concentration I showed you before, we need 250 tons of ore, or 750 tons of brine in Bolivia or Chile. So just 1 ton you handle, you pump, you crystallize, you transfer from the mountain to the valley, 700 tons. Now if you go to the seaside, 5 million of cubic meter of water to recover 1 ton. But it's still working, this project, funded by the 2 governments. In the other side, to recover 1 ton of lithium, you just need 20 tons of portable batteries. Because the concentration is not 0.025, but the concentration is 3%. And in the future, just 240 cars, electrical cars, allow you to recover 1 ton of batteries, because we need around 100 lithium 100 grams of lithium for 1 kilowatt. We shift to the rare earth. Is not disputable. Everyone knows that the rare earths are everywhere in a very, very common and strategic material everywhere. And you see that in magnet, in batteries, in catalysts, in glass, everywhere there is rare earth. Without rare earth, decrease of the big floor of the industry. For one turbine, to make 1 megawatt, you use 500 kg minimum of neodymium. So rare earths are really rare, except in 2 or 3 sites in the world. And the most important is in China, 2.8%. Inner Mongolia is the richest deposit in the world with 2.8%. 2.8 is the richest deposit in the world. However, in those products, we have between 9 and 15% of rare earth. But they are mixed with nickel, with KOH, with steel, so we need advanced technology to recover them. But when the rare earth jump to an unacceptable price, this will be the source. So now we finish with the solar cells. Solar cells is one of the key in the energy transition, definitely. And we have also to anticipate those kind of solar panels, because it's arrived. Those two are in the global area. You know by what? By the bird. It's unbelievable, because they start small, I don't know how we said in English, small failure, and with the cold in the night and the warm in the day, this continue and destroy the solar panel. So now we have to anticipate also the life of solar panel in order that we keep it as a key in the energetic transition. So solar panel is really also a multi-layer of strategic compound, like special polymers, active layer, glass, special glass, etc., etc. And today, solar panels are converted to strategic metals. Like this is connecting metal, this is the active layer, this is a mix of polymer, and this is very clean glass for the first layer. And as you can see, there is no metallurgy, no energy intensity. It's just some smart physical sorting at room temperature. And here in the future, because here we concentrate the chemistry of the active layer. Today we are looking to copper, gallium, indium, selenium, and silicon, but we have to anticipate every new chemistry. For instance, I discovered a huge work of the team of Professor Subot on the perovskite. So anticipation of recycling is crucial. And mainly if we use in the future other products more critical, like, indium or like uranium. So we have to anticipate at the beginning. We have to concept the solar cell in the optic of recycling. This is the eco-conception. Screen around us, I go very fast because everyone knows that they are really source of strategic metals. And we can convert it. We don't speak about this, but we speak what we gain. For instance, here we can make ceramics. Here we make copper. We can recover the lead. Here there is 25% of lead.